Okay, this is Unit 3, and we're in the fluid subsystem, and we're going to be looking at fluid rate. Okay, now with fluid rate, one of the main things we're going to look at is volume flow rate. All right, and basically what it is it's the amount of volume that's displaced in a certain amount of time. Volume flow rate is going to be the Q sub V. Q is flow rate, and then the V here shows you what type of flow rate, because there are many different types of flow rate. And then your capital V here is going to be your volume, and your T is going to be time. An example of this is if you worked for a company that had to assess a flow rate in a house that was being sold. Like a lot of times when you go to get a loan, they make certain professionals come in and assess the house, like termites and that kind of stuff. One of the things they sometimes do is they check volume flow rate. So what they would do is they would open up the taps. Sometimes they let them run for a couple hours. And then they would take a gallon jug and they would fill the gallon jug, and they would time how long it takes to fill the gallon jug. The gallon is the volume. The time with the stopwatch, that's your time. And so the volume divided by the time is going to be your volume flow rate, and it has to fall within a certain parameters. But that would be an example. You were outside and you're watering your flowers, and somebody's messing with you and they start bending the hose. Your volume flow rate is going to change, okay? Or you put your thumb over it, you're going to change the volume flow rate. But anyway, that's your volume flow rate. Okay, so we have our chart here. And like I said, you got your QV for volume flow rate, V for volume, and T for time. Let's take a look at volume first. Volume is going to be gallons in the English, liters in the SI. Okay. Now these are not equal. Okay. A liter is more equal to about a quart. And your time, it can be whatever you need it to be. It could be minutes, it could be hours, it could be seconds. So that's what you have here. And I just made them different so that you could see. All right. So what's going to happen, since you're taking volume divided by time, your volume flow rate is going to be gallons divided by minutes. So you get gallons per minute. Here, liters divided by hours, so you're going to get liters per hour. It's very important that you see that, because I'll tell you right now, when it comes to doing problems in science, units are everything. All right, that's how you pick them out of the problems. That is the trick. All right, you need to make sure you know your units. And by the way, one of my students had said they were having some trouble. You have to know, like we talked about gallons back in a previous fluid section. All right, you might need to go back and preview some of those PowerPoints that we've had. So, I mean, it's okay to do that. They're open for you to do that. Okay, one of the things that we were talking about fluid speed. All right, the speed of a fluid doesn't take into consideration the size of the flow pipe. It doesn't tell you how much flow rate. Okay, so a lot of times we have trouble with the two. All right, let's do a problem. A tank holds 10,000 gallons. It takes 4 hours to fill the tank with water running at a steady rate. And you have to say steady rate, because otherwise you're going to have a whole bunch of problems there. So it's going to be at a steady rate. What is the volume flow rate in gallons per minute? All right, so if you want it in minutes, you're going to take your 4 hours from up here, and you're going to have to change it into minutes. So 4 hours times 60 minutes per hour. The hours cancel out. 4 times 60 gives you 240. And you're left with 240 minutes. Volume divided by time. All right, so 10,000 gallons divided by 240 minutes, going to give you 41.7 gallons per minute. Now, where would you need to know that? If you worked for a community swimming club, all right, and you're filling the pools, for the opening day, you need to know how much it's going to take. How long is it going to take? How long can you run the water, depending on a lot of things, like, are you on a well or are you on public water? Those kind of things. Another one would be for volume flow rate if you work for the water company for your community. If you work for, let's say, some petroleum company, and you are either filling tanks, well, actually like tankers, or you are, pumping out tankers, you would need to know flow rate. Okay, the other one is called mass flow rate. Okay, mass. So mass flow rate is going to be the mass of the fluid displaced divided by the elapsed time. Now, why are we talking mass instead of volume? Because there are some fluids, like gases, for example. Many times gases are measured by mass. They're measured by kilograms or pounds. Okay, so what we have here is QM. Remember, Q is always flow rate. And then you have a subscript here. Your M is going to tell you what kind. It's mass flow rate. Equals mass divided by time. So that's where we get our variables. Okay, let's look at the English mass. Pound for English. Kilograms, all right, for the SI. Time could be anything. Minutes, seconds, hours. I chose minutes here. So mass divided by time is going to be pounds divided by minutes. So we got our mass flow rate. Kilograms divided by seconds gives us kilograms per second. Okay, makes sense. Now, where would you be interested and where would it be important to you? If you work for the gas company and you need to look at flow rate, you might work for a company where they actually deliver tanks, propane tanks. You're cooking on the barbecue, you want to know flow rate. Okay, you also want to know pressure. So that all comes in handy from way back when. If you, let's say, you like to scuba dive, all right, you got tanks. If you're a welder, there's so many places that you would want to know where you use any kind of gas. If you do any kind of glass fusing, that kind of thing, you're going to be dealing with usually propane and oxygen tanks. So there's a lot of places that you can use it, more than you would think. All right, an example. You have 180 kilograms of ammonia gas flow through the cooling coils of a refrigerator truck in 6 minutes. Okay, so if you're looking at the flow rate here, what's the mass flow rate of the gas? All right, for the cooling coils of that truck. It would be like if you are making deliveries, if you drive tractor trailer and you have a refrigerated truck. Okay, it would be important to know. So 180 kilograms divided by your time, which would be 6 minutes, will give you 30 kilograms per minute. We didn't have any changes here as far as units. It's just kilograms per minute. 180 divided by 6 will give you 30. Okay, some applications. And I've been giving you applications all throughout this PowerPoint. Bottling plants, you work for Pepsi, Coca-Cola, one of those. All right, fluid rate is going to be important. I already talked about water supplies, firefighting. Power tools, all right, pneumatic power tools. Controlling heating, all right, you are putting in gas furnace. You're putting in a, I'm trying to think, the oil, all right, oil furnace. Cooling conveyors, all right, excavation. There's a lot of places that you need to deal with fluid rate. So that's just a few examples. All right, that wraps up our fluid rate for today. It was rather short compared to the rest. Don't forget to make sure that you go through this thoroughly before you try the worksheet. Have a good week.